Hey there, this is Max, and we're talking about the FD Poison Exercise 1 solution. So, in the exercise, you're supposed to use the FD Poison technique to overwrite the address of important string. And this is one of those fill in the blank style things, and I hope you played around with GDB a good amount to see how things work. So, if we go to the next screen, we can see that we have a use after free vulnerability within data. Right now, the structure is set up such that it's tcache bin, data, and then data2, and we are able to write into data. And this code shows it pretty well. We have a call to free, and then right after that, we have a call to fgets in data, and this data hasn't been reallocated, which gives us a use after free on the freed chunk. And as a recap, this is particularly nice because we can just edit the FD pointer and try to get malloc to return a chunk that doesn't exist. So data is pointing to the next chunk. It's just a linked list. And by editing the FD, we're able to control the pointer that is going to be referenced at. Now, we can control that and set it to anything we want. In this case, we want to overwrite the address of the important string. And this was given to you. You also could have used GDB in order to look this up with the print command because we have debugging symbols in here. But the end goal is to have data's FD pointer just be set to the address of important string, so that when we do one allocation, it will take off data. And then we do one more allocation, it sets the address of victim to be what we have here. So once we do this final write with which has the pointer name victim, then we just corrupt it and we change the important string to be whatever we want. This technique's pretty simple, I think, and I really enjoy the simplicity in it. Once you understand the data structure of linked lists, like, oh, what if I just change an element? It's really nice. So now if we go into GDB, we can actually see how to solve this. So if you do start.py, go in here, we need to know what the address is. And say I didn't know what the address was, I can do start.py. Once again, I can do print important string and get a reference to that, and I can just use that address. So I just got to change this one to do, and then it will pack it for me in a moment. Now if you want to see this happen a little bit better, we can do a breakpoint on main, and we can do some next, and we can do that until we actually have some stuff in here. So to begin with, we only have the one thing in the tcache bin. If you do a few more next, maybe we'll have some more. I did too many, but that's okay. We go from here, we free data2, and then once we free data2, we then overwrite the reference to data2 in data to our important string. So now if you do a few more next, now all is left is the address of important string. If you do a few more next after that, we see that that's gone. And this just doesn't have a real pointer anymore. This is GDB being confused in all likelihood because you can't allocate any other things anyway. So if we do print victim, we'll notice that this is the address of important string. And it now has a value of deadbeef. So this demonstrates that we were in fact able to trick malloc in order to return a chunk that it should not return. This is not something that malloc should be handling, but nonetheless, we're able to trick it to do that, which is really cool. Now, we'll actually be returning back to this exercise if you would like to do the pointer mangling steps. You don't have to do pointer mangling. This is what you just saw is what I taught in my course for most part. But if you want some extra stuff to do, want to learn about pointer mangling, there is a pointer mangling version of this as well. Well, great job completing the exercise. I think this is a really fun one. It's one of those bread and butter techniques, and it's really good to learn. See you in the next video.